All
Another
right.
episode of John and Ed's TED Talk Together Tuesday.
Let's do it, man. Getting after it. Okay. So today, part 2 of our telemetry work that we're working on. Now we're going to just jump right into it. No joking around, not having fun. Just going to go straight tech right away.
Straight tech, right into it, continuing off right from our whole local setup. So basically kind of putting it together and picking up where we left off. So the last time we went over deploying the application locally, implementing a lot of the open telemetry, and then being able to visualize it locally. So now today we're going to we've moved that code over into AWS, and now we want to see what those metrics and telemetry actually looks like in AWS. So we can get straight into it. So,
let's do it. We're ready to go.
Let's share my screen now. Let's do it. Straight into it. All right, you are going to have to tell me if it comes out weird or not, though, because I have a large screen. So tell me if you can see it or not.
All right, it's loading. Looks fine.
Great. So from the last time, when we deployed it locally, and I will go ahead and add a box here. This is how our local environment was set up. So when we moved it to AWS, this changed a little bit.
Can you zoom in a little bit just so that, because I can see the different boxes, but I can't read what you have in the different sections.
Yes, I can. No, I can't. How do I?
And then maybe let's just do a recap for anyone who hasn't watched or didn't watch recently what this example application does.
Yeah.
Just so we know the context.
Absolutely. So this example application that we built is a pretty simple blog application. However, it's designed in a common way, so it can be replicated across a multitude of different architectures and environments. So we have a React front end that has a blog application, and it has a Node.js backend with a couple different APIs. So we have a posts API, which is for all the blog posts. This API is responsible for retrieving not just all the posts that are available, but also retrieving the IDs of specific posts for users and deleting posts as well. And then we also have a users API here. And that user API is responsible for creating users on the blog. So there's two types of users. There's a admin user, and then there's this a regular user, which can then go and log into the system, create blog posts, delete blog posts. And then an admin has a little bit higher elevation, like a typical production application, where they're really in charge of managing users, upkeep, resetting passwords, different things like that. And then this API service has a MongoDB backend, which is responsible for both the posts and the users that then go and get retrieved and then displayed back on the front end here. So pretty straightforward application, but now that we've taken all that telemetry and kind of gone in depth on how that looks at a local level, we want to see, oh, that's great, but how does that look in AWS, right? Like, how do we get observability? How do we see what we covered last time is like we have our telemetry pipeline here, right? So with the telemetry pipeline, we have our different applications, and depending how they're instrumented, in our case, we'll be using the EC2 instance here. So I've gone and deployed our code onto 2 different EC2 instances, one for our front end, one for our back end. But this is still applicable for if you've deployed your application into ECS or using Kubernetes via EKS, or if you have Lambda on-prem Kubernetes or even VMs outside. So today we'll be covering the trace data and the log data telemetry pipelines.
Okay.
And then the follow-up for part 3 is we'll be going over shipping our metrics from Prometheus and then using visualization via Grafana for the metrics pipeline. So today we'll be going over what traces look like using AWS X-Ray, because we have all AWS native services deployed out. And then for our logs, we'll be using our CloudWatch logs, and then how this looks for our logging pipeline. So a couple different things that change going from a local to an AWS environment is because all of this was hosted locally, it was very easy for network communication to happen and everything. And going to an AWS environment, AWS dev environment, there's a couple additional hops here that happen now. So instead of going straight to a little bigger. We'll now have an ALB, which is an application load balancer. The application load balancer will then point to our front-end blog application. That is hosted on EC2 in a public subnet following best practice architecture and implementation. And our front end will now also have an ALB in front as well. So now our front end application on an EC2 instance in a public subnet is going to talk to our ALB. And then our ALB is then going to route traffic to our backend API, which in this case is now hosted on an EC2 instance in a private subnet. And for this example, our MongoDB instance is also hosted on this same EC2 instance. So I'll go ahead and make this include both of those.
Got it.
And make this a little prettier. So again, pretty straightforward, but now we can see how similar into a production environment, how many hops have to actually occur. And it's not as simple as A, B, C. Now we have a kind of different visualization of what's actually going to be happening. And this is why your end-to-end tracing is so important, because your end-to-end tracing is actually going to be able to show you all these different hops and see where there's opportunities for enhancement, or if you're experiencing performance degradation or something of that nature. Now, in addition to showing the metrics pipeline next week, we'll actually show an end-to-end telemetry pipeline for our traces from front end all the way to back end. In this case right now, we're going to be focusing on this part of the, make this a little bit bolder.
The second load balancer and then the private subnet.
This is correct. So we're basically
Good.
going to be showing it kind of the isolated to help with the visualization of just how a backend application trace is going to happen. So we're going to show the request coming in from the application load balancer from our front end. It's going to be hitting our application code and then making a MongoDB call and then returning that response. So this is the part that we'll be focusing on right now. So let me duplicate this. From your AWS console, if you come into CloudWatch, and you can access it also by just typing in CloudWatch up here in the search bar. This will bring you to just the CloudWatch homepage here. And then under the section X-ray traces, you can go ahead and click that. And then it'll bring you over into the dashboard where you can then go filter your X-ray group, find traces, narrow it down by node. These are the different nodes we currently have deployed. And then it'll give you actually a list of traces organized by most recent. So we can see here that we have 3 different nodes. And what does that mean, right? So we can see here that we have a node called example backend dev, blog app, and blog app, and then with just a local host IP address, which is 127.0.0.1. So for all my nerdy dev people out there, there's no place like 127.0.0.1, which means there's no place like home for those non-IT nerds. And we can see here that we have a variety of trace data actually coming in for the time period that we're looking at here. And we can actually see the number of traces that came in and their P50, P95, and P99, which this is talking about percentiles. So our average, which is basically going to be our average response time, is a little over 5 milliseconds currently. P95 is at 10 milliseconds, and P99 is under 15 milliseconds. This is going to go back into establishing like your SLIs, SLOs from an SRE mindset. So basically, we can see from here that our P99, meaning 99% of our requests are happening under 15 milliseconds. In our case, it's exactly 13 milliseconds is our P99. So when you establish your SLIs and SLOs, one of those could be your requests, your P99 or P95, whatever you and your stakeholders establish those on, could be 99% of our requests have to happen in X amount of time. And then if you get an alert or something of that nature, now you can go in and be like, we've reached our threshold, our SLO is broken, what happened? And then you come in here, you start seeing, oh, I had a spike. In our case, obviously it's performing well, but we can kind of visualize like, oh man, if I had a spike where I broke my P99 threshold, causing it to go over whatever I defined as that threshold, then we can go ahead and start investigating those different traces to kind of see where that happened. That's why it's so important to instrument tracing in your telemetry. So I can see here we have a bunch of 200 response codes, which is fantastic. And kind of just where it's coming from. So the reason we have this URL address actually is because our ALB is checking this for its health checks right now to see if it's a healthy host or not. But to understand where our traffic is coming from, now normally you would set up a separate health check endpoint. And normally that health check endpoint would also include deep health checks, which would then check if, for instance, your database instance was up and running. So our deep health check could go pass as healthy if MongoDB is up in our case, and if MongoDB is up, our application should be up and then should return a 200 response code. However, I haven't configured a health check for this example application, so I have it pointing to just our post endpoint to see if it's up and running. And then when I was testing connectivity, we can see here, there's this localhost post right here. And this is actually coming from the front end application, basically using curl commands. But for our example, oh, not that part. For our example, focusing on this, we want to see our client being this ALB in front of our backend here. And I can see here that our URL address for some of these traces with a 200 response code are this internal testing, and the keyword here is ELB, and then the endpoint here. So we have an elastic load balancer, and that's going to actually be our ALB, where this is coming from. So I'll go ahead and click on this trace to get a visualization of how this part of our flow is actually working. So I can see from our client, which is our application load balancer, being routed to our Node.js application. And then I actually see two different calls here. And depending on how you want to visualize this data, you can just show icons if you don't want to see metrics. I'm interested in seeing the metrics. So from here, we can see that our client gets to our backend application in an average of 5 milliseconds. And we have less than 0.01 requests per minute. So this comes down to like your transactions per second or TPS. I can also see that there's a blog app at localhost being called with a less than 1 millisecond response time, and another call happening to our blog app with an average of 3 milliseconds and 0.01 TPS. Now the reason this is, oh, go ahead.
Quick question. The load
Yeah.
balancer is just splitting it between the local and then the other instance. So that
great
it
question.
balances the load equally. Is that right?
Yeah, exactly. So in a production environment, you would basically have this one client, and you could have a bunch of different backend services, and that ALB would be responsible for routing traffic over to every single one of these instances of your backend application. So for a Kubernetes application, for example, you could have it routing it to a bunch of different pods on the backend to make sure that you're able to handle all of your load, which is the reason why we simulated that kind of environment by putting an ALB in front of our backend application. Absolutely right, Ed. Now,
Never say that I don't know anything about tech.
You're super technical, Ed. You're downplaying yourself. I know you are. So there's a couple different things. So last week we covered how these traces looked in what we call Jaeger, which is just an open source telemetry tool. And we can see here that it's very similar to how that looks from a UI perspective. I can see here that the ALB was called using this GET request. It went, hit our middleware, CORS middleware here. We have a router service within our application, a request handler, which then goes and hits our API/posts. And then there's two different blog apps here. one from a local host and then one from just called blog app here. Now, the reason this is important because I actually added this second call into the application code to show that when we have a trace visualization tool, it's super powerful to see areas of opportunity when you are getting these calls. So in this case, if I wanted to improve this, like if I was seeing high response times or like wondering why requests were getting sent back in a time that didn't look normal, I would come to my trace. And in my case, I should only see one backend call to our database, actually. I should see just a one GET call to get all the posts from the database, query the database, and then send the response back. However, since I'm seeing two here. So this is a great opportunity to be like, why is my backend application making two calls to my backend and adding basically time to the entire request? So this is where your developers and or operations teams would then go in debugging and troubleshooting and understanding this trace and understanding where this came from. Which again, super important when you have this telemetry, because now I can see where in the entire trace these are kind of happening at here, right? So I have this blog app call happening, and then a blog app at 127.0.0.1 happening. They're both remote calls, and then I can see how long it actually took from each of those different requests. So this is where I would go then and begin going through my code and understanding, okay, in my request handler for API posts, there's something that happens within this stack trace that I'm making two calls when I shouldn't be. And then you go and optimize it, and then your response time increases or decreases actually, and you get better performance overall. So that's one use case of having telemetry and traces instrumented, and then using X-ray to actually go and then basically troubleshoot that entire trace to improve it. The same thing, we can actually go. We go back to traces. It can also be super helpful for 400 errors. That stopped twitching. And to actually get this error to generate, I can see here that it was called using this endpoint. So if I open this now, I can see that we were hitting our front-end application, but no calls were getting made to our database, which is not expected behavior. And then we want to see basically this 400 error on what it was actually getting returned, right? And so this is where you would go grab like your date timestamp, and then you can go correlate this with your logs to see exactly why this was getting returned as a 400. Now in our case, I know this was getting returned as a 400 response code because the application actually doesn't have an endpoint for just posts. Our endpoint is actually /API/posts. So by me making a call that wasn't instrumented and or existent in this case, that's why we got this 404 response code. So again, another super powerful tool to see what your error rate is at, which again, going back to SLIs, SLOs, this could be like your error budget. When you set up an error budget, it could be you are expecting 99% success rate, right? And so you're allowed 1% of errors of whatever your TPS or expected response count over a time period is going to be before you actually breach that threshold. So if you have your SLOs configured, you could see, why is my error budget decreasing? Why am I seeing a lot more errors? You come into your traces, you can see that you do have a lot more errors. Get date timestamps so then you can go and correlate with your logs.
And this is a place where in part 3, we'll tie in how it visualizes with Grafana, right? So having the right tags that look for specific events so that we can call out at a human level and easily dive into anything that is an outlier. Is that right?
Yeah, absolutely. So the whole point of all of this is actually to be able to correlate all the different tools that we're using, combining that data, and then being able to tell a story from that data. And so in part 3, we'll go over, okay, how do I use this date timestamp from this trace to correlate to my metrics, to my logs, and how does all that go into, which it's kind of an art in itself, being able to debug and troubleshoot and get into that operations and debugging. And so it's something I'm super passionate about. So I'm going to love walking through all that different correlation and being able to tell that story from a user journey perspective, which will be fun.
Cool, thanks.
Yeah, absolutely. So another thing is, if using this trace data, if we see this error 400 and we're not able to actually relate this to any metrics or logs, then that's showing that we have a gap in our observability, and then we should account for that. And normally this is where like a root cause analysis or blameless postmortem, depending on how your organization uses those terms, would then go and reveal. So for example, we're seeing a bunch of 400 errors in our traces. We got an alert for it, but we're not able to see that in our either our logs or our metrics. Well then, okay, in our postmortem or RCA, root cause analysis, be like, we found X, Y, Z, or if you follow like the 5 Ys, depending on how you do that, you dig into why it occurred, and then how do you repeat or prevent that from happening again. And one of those outcomes could be instrumenting additional observability or custom metrics into your application to make this storytelling a lot easier. So now, this is covering our trace data here. So we've covered how our traces look from our backend application using X-ray. But now we want to go ahead and take a look at our logs. And just a little bit more insight on to how this was actually instrumented is with the CloudWatch agent, you're actually able to configure the different endpoints on what it's looking for, and then that agent from the EC2 instance goes and pulls that data and then ships it to the desired platform. So with OpenTelemetry, there's an actual AWS distro for OpenTelemetry. So the CloudWatch agent actually natively supports the endpoints that get exposed from the OTel collector, and then go and get them shipped. Now, if you're not interested in using Prometheus or Grafana, you can also configure your CloudWatch agent to ship your metric data to CloudWatch as well, and then see all your metrics in CloudWatch as well.
What would be the pros and cons of doing that versus using Grafana,
Great question. So
Prometheus or Grafana?
yeah, so in the developer community, there's what we call the gap stack, which is Grafana, Alert Manager, and Prometheus. So it's a super common open source tooling that a lot of developers are familiar with and have experience with. So you have basically less time to train, more knowledge transfer, a bigger community of resources, and then just a familiar UI and environment and standard compared to using an AWS native tool where in a sense it's vendor lock. So if you have developers, for example, that came from a Microsoft shop or a GCP shop, they might not have the familiarity with CloudWatch. And so you have that learning curve
Right.
on using CloudWatch. Now, it's not a high learning curve, but it still is a learning curve. And then, in addition to that, Grafana is a great visualization tool that then uses Prometheus as its data source. But Grafana is also powerful in the sense that you can have a ton of different data sources pointing to a single Grafana instance. So for example, if you have a bunch of telemetry data from a bunch of different places, it gives you a great way to centralize all of that data.
Got it.
Compared to CloudWatch, where you might have to either kind of figure out some band-aids to get it, or creating a centralized logging account between all your AWS environments. And then even then, some things might not be compatible with CloudWatch, or you're coming up with more tech debt trying to figure out how to send it into CloudWatch. So Grafana, there's a, oh, go ahead.
So let me just summarize that, what I heard. Is that, sorry for interrupting you.
No, you're good.
Okay, so for example, say I'm a customer that has 4 different applications in 3 different environments, and I wanted to visualize it. Well, if I wanted to keep everything totally AWS native, then I would figure out how to send all of the application logs from those 4 different applications across 3 environments into one localized logging environment, and then make sure all the permissions are right. And now I'm creating a not full Cartesian explosion of, you know, different possibilities, but you're adding kind of this multiplicative layer of complexity versus sending the 4 different logging streams, regardless of their environment, into Grafana.
Yeah, and exactly. And on top of that, because there's such a huge community for Grafana, it allows you to get up and running a lot faster. So for example, with React and Node.js and whatever basically languages you're using, there's probably already a community that's created optimized dashboards using the standard open telemetry metrics that come out. And so you can take someone else's dashboard of maybe like HTTP request or response times or error rate, different things like that, import it, and then be able to hit the ground running basically. So super fast. And then in addition to that, if you have any on-prem workloads or workloads outside of AWS, you can also use Grafana as a visualization tool for that as well. So maybe you're hosting maybe some on-prem Elasticsearch clusters, or maybe you're using Splunk for logging as well. You're also able to add those data sources. So it's a very, again, powerful centralization tool.
Right. And so it's simpler, and then you're not having to recreate the wheel with your visualizations every time. You can actually get the benefit of the work that other people are doing.
Yeah, absolutely. Super powerful, which is why we recommend it. It's and it's just a community favorite too. A lot of people love Grafana, working with it. It's very easy.
So this holistically, I know that there's a lot of technical steps along the way, but if you zoom out, the things that we're doing are pretty simple,
Yeah. Yep.
right? It's basically finding the signal, finding the places within your application, the process of how your application works, that you want to have a signal to read the activity, and then making sure to tell that where you want it to log. And then once it's logged, telling it how you want to use it, which we'll get into that piece next week, but you could even use it within just CloudWatch natively if you had a very simple solution, right?
Yeah, absolutely. Yeah, there's nothing super crazy about getting up and running. Um, for the CloudWatch agent, for example, it's as simple as passing in a JSON file with your configuration saying, hey, this is where my log files are at. Go get this and ship it to CloudWatch. Or, hey, this is where my traces are coming from. Scrape that and ship it over there. Same thing with the metric. So AWS has done a really good job of making it super easy to get up and running and not let them be the speed bump to your telemetry. So actually, I don't know if I have it pulled up here. Let's see if I have the JSON file that I used off the top of video. So let's just show how that looks. Okay, so this is actually the Cloud Agent JSON file that I've used, and you can see here it's
Okay.
it's only 32 lines of code that I added to my EC2 instance, in which the Cloud Agent or CloudWatch agent on the EC2 instance picked this up and then started shipping with the telemetry over, which was fantastic. So there's two different places that I wanted logs collected from. So underneath our logs
Could you
section
zoom
here.
in a little bit? It's a little
Oh yeah,
far out.
absolutely. Oh, can I not? Oh, let me figure out how to do that. Can I zoom in more? Wow, not really gonna let me. Please hold.
That's all right. We could share these artifacts in case somebody wanted to know it or see what you did, right?
Yep,
Okay.
and we'll actually be able to see it in the CloudWatch logs right now. I don't know why it didn't let me zoom in though. Normally it's,
That's all right.
but yes. So underneath our log section here, there's two different logs I'm shipping. I have our our CloudWatch agent log, and then our backend log. And there's a couple different, depending on your organization. Again, there's a couple different logs you might want to ship. You might also decide that you want your error log in a different directory and your informational logging in its own directory. Or maybe you want to also maybe split out your API calls into its own log file, different things like that. So you can have a bunch of different log files being written and then have all of those shipped and be able to separate out that as well. In my case, I have everything writing to one log file for the application, and that's more just for ease of use, being able to correlate all my messages from info, debug, and my error messages as well. And then at the bottom of here, I give it a log stream name, which we'll see here in the console. And then from a traces perspective, I tell it which endpoint our traces are actually exposed to. So once you have all that configured, let's see how that actually looks in CloudWatch. Do I have our logs open? I do. So coming, same thing from CloudWatch, where you were able to access the X-ray traces. You have under logs, log groups, and log insights. So I've gone to the log group and I've selected our BUILDSTR backend.log, which is the same log stream name that I used on our CloudWatch JSON here. And I can actually see now all the logs that are being shipped from that EC2 instance. And
Got it.
if you actually back up one more step, you can see all the different log streams here. And then there's a couple different tabs for all the different settings, including anomaly detection. But I'll go ahead and just pull up our logs and kind of visualize how these look. Now, depending on what language and what standards you're actually using, your log messages might actually look a lot different than this. But I've gone ahead and formatted all of our logging to resemble JSON to make it easy to read. So I can see here that this is for my dev environment. This is the level. And then this is actually the logging message that is being sent. And then these are all different tags, such as the service name, what version, and then the timestamp. And then we can see here that my region is none, but this should actually be populating the AWS region. So it means I messed up configuring our environment variables, but that's what this is for, to learn. So, and understanding your application here. So I can see that there were a couple different things that I've done here. There were a couple user creations and then a couple posts created as well. And I could go and view these. So I can see a regular user was created, an admin user was created. There was a post created titled first post, and then a timestamp. Now, I've also included some error messages. So I can go ahead and search my log events for the keyword error. And then I can see now that a bunch of error messages have appeared here, as well as with the stack trace. So I have a message for fail to initialize collection sizes when reading a collection. And basically this is like a malformed payload hitting the API, which triggered this error. So now I can go and say, okay, I see this error. It's failed to initialize. Here's in the code where it happened. Let's go investigate that. And this was to show custom error messages. So you can also have additional error messages. So like, for example, from your, that signed up. So if you were seeing the 400 responses in your traces, but you weren't able to see them in your logs, that's where you would go, okay, I should see them in my logs. You would go add code to your application, which would basically kind of, in my case, I have a custom logger, but if you might have output being read into a console or something of that nature, you would add that basically a print line saying error message and then format it in a way that makes sense for you so you understand the error, where it's coming from, how do you debug and troubleshoot that, and or create additional testing before you deploy to your production environment.
So anytime that you're doing this, you really need to go through, set up the parameters of what are the different signals that we want to record, and then validate at the end. Okay, are we capturing everything? Did something occur that we didn't capture? How do we adjust that? And then on top of that, say you've got everything buttoned up and you're ready to go, you push this to production, you can always go back in and make modifications later to increase the number of signals that your system is of the telemetry that your system is looking for.
Yep, absolutely. So this might also be a case where this might be too much information that you're exporting, right? And so maybe we don't want our info logs. Maybe we don't care about info. And what I mean by info is you can assign different levels to your logging messages, and you may only want to see error messages. Info and debug may be too cumbersome and may take up a lot of space and could cost you money in the long run. And so it might make sense like, hey, I'm seeing a bunch of this. This is not going to help me reduce my time to detect or time to mitigate. It's useless in production. I only want my error messages.
Got it.
And so
sorry, and one other question. Could you also capture all the logs and then only visualize whatever you know, a smaller portion of that?
Yeah.
So like maybe you want all of that information that's too much information, but you only want you only want that as a just in case to go back and look at post hoc, but you want to visualize other key things that are more immediately pertinent.
Yeah, absolutely. So by standardizing your logging standard and the message that's being outwritten, you can actually say, maybe I don't care about the dev environment. I only want production logs at this error level, or maybe even for this service or whatever of that. So you use your tags and your variables to then go ahead and filter your results, and then you can visualize your results as well. So for log visualization, there's a couple different tools you can use. Again, we can use Grafana if we do decide to use this as a data source, or we can also use AWS native tools such as Log Insights, which is kind of fun because you can basically use a query language to then go and filter and generate the logs in different patterns and visualization as well. I haven't configured our logs to actually use Log Insights, but it should be as simple as maybe doing piping into something where the message is something like error or something of that nature. And then you would go ahead, run that query, and then you'd be able to visualize it as well. So maybe, for example, yeah, I haven't actually configured these with our logs, which is why our query language isn't performing. But enabling this is an easy fix to your application format and your logging standard. So depending if you want to use Log Insights for visualization or something else like Grafana or Elasticsearch or something like that. So to recap, we've covered, where is,
Going back to our picture.
yeah.
Great.
So we've covered our trace data using the OpenTelemetry connector for traces and X-ray, and then our log data and shipping it to CloudWatch for our backend application. So next week, we'll go over how metrics actually look being shipped to Prometheus and Grafana for visualization, as well as what does an end-to-end trace look like, meaning Meaning, how does the trace look coming from our ALB in front of our front-end application, coming from our front-end application, and then covering this part. And then end-to-end tracing is what's really, one, super powerful, but two, basically like the Datadog equivalent as well, because Datadog does a really good job of giving you that end-to-end tracing, but we'll be able to see the same end-to-end tracing using X-ray in this case that Datadog would provide for this same application architecture.
Yeah, that'll be great to see. And then maybe going back to the comparison perspective, could we also show what log insights and or if you wanted to deploy it to like a S3 tables and point that to QuickSight so we could just see the different kind of permutations of what people could do?
Yeah, absolutely. We can go through a couple different use cases on how people are using their data once they have it stored, organized, and ready for congestion. Absolutely.
Great. I love it.
Congestion, consumption.
Consumption and ingestion. Congestion. It's a new technical term.
You picked up what I was laying down.
Oh, yeah. I'm tracking. Well, Johnny T, thank you for putting this together to walk us through this. I think that helping have this abstracted concept so that people who are interested in it could go, oh, well, I have an application. It's a lot more complicated than that, but I could see how this simplified version could then be scaled out to what we're doing. Hopefully that's very helpful for people.
I hope so too, because man, I remember when I was first going into the DevOps and SRE route, and my first application looking at a trace, and it's like it's like it's overwhelming. Like, so I think toning it down and saying, okay, A, B, C, foundational level, and then you're able to take those same foundations and apply it to applications at extreme scale, which I know will help a ton of people being able to correlate that.
Cool. All right, my man. Well, look forward to our session next week, part 3, and the end-to-end picture of what it looks like once you have your data and you want to start visualizing it and making it actionable.
Absolutely. Super exciting. Part 3 next week.
Part 3.
Let's do it. Yep.
Rock and roll. Here we go.
Till next
Peace out,
time.
everybody.